Objectives. At the end of the course, students will be able to understand about the basics of database, know the components of database, explore the applications of database, understand the concept of database management system. What is data? In simple words, data can be facts related to any object in consideration. For example, your name, age, height, weight, etc. are some of the data related to you. A picture, image, file, PDF, etc. can also be considered as a data. Now, what is database? This data could be random. A database is a systematic collection of data. Since the data in a database is organized, it makes data management easy. What is database? Database Management System (DBMS) is a collection of programs which enables its user to access database, manipulate data, and help in representation of data. It also helps to control access to the database by various users. An online telephone directory would definitely use database management system to store data pertaining to people, phone numbers, and other contact details. Let's also consider the Facebook. It needs to store, manipulate, and present data related to members, their friends, member activities, messages, advertisement, and a lot more. Navigational DBMS, Relational DBMS, SQL DBMS, Object-Oriented DBMS. Purpose of database. In the early days, database applications were built directly on top of file systems. Drawbacks of using file system to store data. Data redundancy and inconsistency. Multiple file formats, duplication of information in different files. Difficulty in accessing data. Need to write a new program to carry out each new task. Data isolation. Multiple files and formats. Integrity problems. Integrity constraints become buried in program code rather than being stated explicitly, and it is hard to add new constraints or change existing ones. Atomicity of updates. Failure may leave database in an inconsistent state with partial updates carried out. Concurrent access by multiple users. Uncontrolled concurrent accesses can lead to inconsistencies. Security problems. Hard to provide user access to some data, but not all the data. Database system offers solutions to all the above problems. OLTP, that is Online Transaction Processing, is a class of software programs which is capable of supporting transaction-oriented applications on the internet. OLTP database handles real-time transactions that commonly have some sort of special requirements. Database design. The process of designing the general structure of the database is categorized into two types: logical design, physical design. Logical design. Deciding on the database schema, database design requires that you find a good collection of relation schemas and data. Logical design is more conceptual and abstract than the physical design, where user will look at the logical relationships among the objects. Physical design. During the physical design process, user convert the data gathered during the logical design phase into a description of the physical database as table and constraints. In the physical design, user will look at the most effective way of storing and retrieving the objects. Process for database design. Analyze business needs and plans. This is the remaining steps. Draft a database outline. Gather all of the types of information to record in the database, such as product name and order number. Check system requirements. Divide information items into major entities or subjects such as products or orders. Each subject then become a table. Last test data. Decide what information needs to be stored in each table. Each item becomes a field and is displayed as a column in the table. Define calculations. Choose each table's primary key. The primary key is a column or a set of columns that is used to uniquely identify each row. An example might be product ID or order ID. Define reports. Look at each table and decide how the data in one table is related to the data in other tables. Add fields to tables or create new tables to clarify the relationships as necessary. Verify with the user. Analyze the design for errors. Create tables and add a few records of sample data. Check if results come from the tables as expected. Make adjustments to the design as needed. Repeat process as needed. Apply the data normalization rules to see if tables are structured correctly. Make adjustments to the tables. Database decade model. Decade 1960s, 1970s, 1980s, 1990s, 2000 plus. Traditional files: hierarchical, network, relational, object oriental, object relational. Charles Bachman, IDS Honeywell, CODASYL, 1960. IBM, IMS Hierarchical Model, 1968. Edgar F. Code, Relational, 1970. Ingress, TM Trademark, Eugene Wong and Michael Stonebreaker, Open Source, QUEL, 1973. Larry Ellison, Software Development Laboratories, Relational Software Incorporated RSI, 1973. IBM, DB2, DB2 Facebook Community System or PNW DB2, Codes Relational Model Mainframes, 1979. Sybase, an SAP company. Mark Huffman, Bob Epstein, Jane Doty, and Tom Hagen Power Bueller. Offshoot of Ingress, 1984. Teradata, NCR Corporation, Data Warehousing, 1984. Microsoft SQL Server 2008 R2. Sybase SQL Server share the source code. Sybase and Microsoft SQL Server were virtually identical. 1989. MySQL, Michael Widenius and David Axmark, Sun Microsystems 2008, Oracle 2010, 1995. SQLite, D. Richard Hipp, RDBMS Embedded, Mozilla Firefox, Skype 2000. Denis Lucia, offshoot of Ingress, 2004. Apple's iOS, where it is used for SMS or MMS, call near, call history, and contact storage. Symbian OS, Nokia's Memo, Google's Android, Google's Chrome browser, RIM's BlackBerry, Linux Foundation's MeGo. Types of database. The various types of database are relational database, distributed database, embedded database, graph database, operational database, spatial database, temporal database, real-time database, hierarchical database, network database, object-oriented database. Relational database. A relational database (RDB) is organized by tables which contains a collective set of multiple data sets. RDB is derived from the mathematical function concept of mapping data sets and was developed by Edgar F. Cord at IBM in 1970. RDB establishes a well-defined relationship between database tables. Tables are represented as columns and rows. Where columns are known as attributes and rows are known as tuples. tables communicate and share information which facilitates data searching ability, organization, and reporting. Each table contains a unique key called primary key, which helps in faster indexing and searching. The other keys, column names, are termed as candidate keys. Tables are related by primary keys and foreign keys. RDB use structured query language, that is SQL, as database queries language that provides an easy programming interface for database interaction. A sample relational database is shown. Advantages: avoids data duplication, easier to change data, easier to maintain data security, avoids inconsistent records. Distributed database. A distributed database is a logically interrelated database distributed over multiple computers within a network. A distributed database stores data across multiple computers and allows transaction among them. A distributed database can reside on the network servers, internets, and extranets. In distributed database, all storage devices are not attached to a common processing unit such as the CPU and are controlled by a distributed database management system. Advantages: higher reliability, improved performance, easier system expansion, transparency of distributed and replicated data. Document-oriented database. Document file, document, model. Document-oriented database is also known as semi-structured data. A document-oriented database is designed for storing, retrieving, and managing document-oriented information. The main concept of a document-oriented database is the notion of a document which encodes in the form of BSON, that is Binary Script Object Notion, JSON, that is JavaScript Object Notion, and XML, that is Extended Markup Language. Advantages: simple and powerful data model, scalable. Disadvantages: poor for interconnected data. Embedded database, an embedded database system is a database management system, that is DBMS, which is designed to provide data to a host application. It is tightly integrated with application software that requires access to stored data such that the database system is hidden from the application's end user and requires little or no ongoing maintenance. Graph database. A graph database is a database that uses graph structures with nodes, edges, and properties to represent and store data. A graph database is any storage system that provides index-free adjacency. Advantages: can easily evolve schemas, can represent semi-structured info. Disadvantages: lacks in tool and framework support, no support for ad hoc queries. Operational database. Operational database (OPDB) is the database of record consisting of system-specific reference data and event data belonging to a transaction update system. Operational database also contains system control data such as indicators, flags, and counters. Operational database is the source of data for the data warehouse to run transactions in business. The operational database is shown here. Spatial database. A spatial database is a database system which offers spatial data types (SDTs) in the data model and query language. Census data. NASA satellites imagery, terabytes of data per day. Weather and climate data. Rivers, farms, ecological impact. Medical imaging. Temporal database.
A temporal database is a database with built-in support for handling data involving time. The temporal aspects usually include valid time, that is start time or end time, and transaction time. Consider the following table. When a row is updated, the database manager saves the original row in an associated history table. Similarly, when a row is deleted, the original row is added to the history. A single query can return all the information for a particular row. Real-time database. A real-time database is a database system which uses real-time processing to handle workloads whose state is constantly changing. A real-time database differs from traditional databases containing persistent data, mostly unaffected by time. For example, a stock market changes very rapidly and is dynamic. A sample real-time traffic info database where updating is done to avoid confusion is shown here. Hierarchical data model. The hierarchical data model is represented by an upside-down tree. The user perceives the hierarchical database as a hierarchy of segments. A segment is the equivalent of a file system's record type. It contains nodes connected by branches. The top node is called the root node or parent node. The parent can have no children. The parent can have one or more children. A hierarchical model can represent a one-to-many relationship between two entities where the two are respectively parent and child. A hierarchical path is a sequence of nodes starting from a root node and follows alternatively from a parent node to a child node. For example, person, staff, student is a part of hierarchical model. Advantages of hierarchical data model: data sharing, data security. Disadvantages of hierarchical data model: inflexibility, database management problems.
Network database.
The network data model is similar to a hierarchical model, except that a record can have multiple parents. The network data model has three basic components such as record types, data items, links, that is set types. Network data model uses a lattice structure in which a record can have many parents as well as many children. In this model, entities are organized in a graph in which some entities can be accessed through several paths. The network data model also consists of nodes and branches, but a child may have multiple parents within the network structure instead of being restricted to just one parent. Advantages of network data model: facilitating more relationship types, data independence, superior data access, database integrity, simplicity. Disadvantages of network data model: not user-friendly, system complexity, absence of structural independence,
Object-oriented database. Object-oriented database is based on the object-oriented programming language paradigm. They store objects rather than data such as integers and strings. Creating objects. Everything in the world is object. Examples of object will be every object has two things. The relationship between various data is embedded to the object and manifests as object attributes and methods. So, let us examine pen object. Objects, database entries, an example of object-oriented database. Object relational data model extends the traditional relational model with a variety of features such as structured and collection types as well as object orientation. Why use a database? Databases are extremely useful for two main reasons: data analysis, data storage. Their management systems are designed to provide their own safety checks and also backup systems to store massive quantities of data safely. Databases are useful because many computing applications are using a large amount of information. Database is easy to add new data and to edit or delete old data. There is ease of storage. Data can be imported into other applications easily. Database also facilitates increased consistency. Database has improved data security. Multiple users can access the same database at the same time. Introduction to database system. A database system is a computer-based record-keeping system whose overall purpose is to record and maintain information that is relevant to the organization necessary for making decisions. Database systems are used in various real-world applications such as banking system and ATM machines. Stock trade. Components of a database system. A database system is composed of 4 components. Data is a distinct piece of information, usually formatted in a special way. Data can exist in a variety of forms, as numbers or text on pieces of paper, as bits and bytes stored in electronic memory, or as facts stored in a person's mind. Data is a very important component of a database system. Most of the organizations generate, store, and process large amount of data. The data acts as a bridge between the machine parts, that is hardware and software, and the users, which directly access it through some application programs. Data may be of different types. User data consists of a table of data called relations, where columns are called fields of attributes and rows are called records for tables. A relation must be structured properly. Metadata basically means a data about a data. It is a description of the structure of the database. Application metadata stores the structure and format of queries, reports, and other application components. Hardware. The hardware consists of a secondary storage devices such as magnetic disk, optical disk, magnetic tapes, etc., on which data is stored together with the input or output devices, processors, main memory, etc. Software. Software part consists of IDMS, which acts as a bridge between the user and the database, or in other words, software that interacts with the user's database and file system of a particular storage medium to insert, update, delete, and retrieve data. Users. Users are those persons who need the information from the database to carry out their primary business responsibilities. The various types of users who can access the databases are Database Administrators. DBA writes the database software itself. Database Designers designs the database software. End users use the database system to store and retrieve data by performing insert, delete, and update operations. Application programmers write software to allow end users to interface with the database system. Applications of database system: banking, airlines and railways, education, credit card transactions, telecommunication, sales. Banking. A banking database system is used to store customer information, accounts, loans, and banking transactions. Database Management System (DBMS). Definition. A database management system stores data in such a way which is easier to retrieve, manipulate, and helps to produce information. Characteristics. The DBMS has the following characteristics. Modern DBMS is more realistic and uses real-world entities to design its architecture. Real-world entity uses the behaviors and attributes too. Relation-based tables. DBMS allows entities and relations to form as a table. This eases the concept of data saving. Just by looking at table names, user can understand the architecture of the database. Isolation of data and application. A database system is entirely different from the data stored in it. A database is said to be an active entity, and data are said to be passive one on which the database works and organizes. Less redundancy. When any of its attributes is having redundancy in values, then DBMS follow rules of normalization which splits a relation. Following normalization, which itself is a mathematically rich, make the entire database to contain as less redundancy as possible. Consistency. Database management system provides consistency where the previous form of data storing applications like file system does not guarantee this. Consistency is a state where every relation in the database remains consistent always. Query language. The DBMS is equipped with query language, which makes database more efficient to modify, retrieve, and manipulate data. A user can apply as many as filtering options as he or she wants. Asset properties. Asset properties, which stands for atomicity, consistency, isolation, and durability. These concepts are applied to transactions which manipulate data in the database. A transaction is an atomic unit of processing and they do not have paths. They cannot be executed partially and it should not be detectable that they interleave with another transaction. The transaction must take the database from one consistent state into another. It is the responsibility of user to ensure consistency. During transaction at the middle, the database might not be consistent. The effects of a transaction must not be made visible to other transactions until it is committed, that is, solves a temporary update problem. This is called isolation or independence. This actually sounds like a consequence of atomicity. Once a transaction has been completed, its updates are made permanent. The updates persist in the database even if there is a subsequent failure. The effect of transaction must remain in place even if the system crashes. Security. Multiple views offer security at some extent where users are unable to access data without authorization and authentication. DBMS offers security to impose constraints while entering data into the database and retrieving data at a later stage. DBMS provides many different levels of security features which enables multiple users to have different view with different features. Architecture of DBMS. The architecture of a database system is greatly influenced by the underlying computer system on which the database system runs. Database system can be centralized or client-server, where one server machine executes work on behalf of multiple client machines. Database system can also be designed to utilize parallel computer architecture. Database applications are usually partitioned into 2 or 3 parts. Two-tier architecture. In two-tier architecture, the user interface and application programs are placed on the client side and the database system on the server side. Two-tier architecture is also called as client-server architecture. The application programs that reside on the client side invoke the IDMS at the server side. The application program interface standards like Open Database Connectivity (ODBC) and Java Database Connectivity (JDBC) are used for interaction between the client system and the server system. Three-tier architecture. The three-tier architecture is a widely used architecture. The client machines acts as merely a front end and does not contain any direct database calls. Instead, the client end communicates with an application server, usually through a forms interface. The application server in turn communicates with the database system to access data. Three-tier architecture are more appropriate for large applications and for applications that run on the World Wide Web. Data model. Data model is the fundamental entity to introduce abstraction in DBMS. Data model defines how the logical structure of a database is modeled. Data models define how data is connected to each other and how it will be processed and stored in the system. Flat data models are the very first data model, where all the data used to be kept in the same plane. Because earlier data models were not so scientific, they introduced lots of duplication and update anomalies. There are 4 models: ER model, relational model, object-based data model, semi-structured data model. ER model. The entity relationship model is based on the notion of real-world entities and their relationship. ER model creates entity set, relationship set, general attributes and constraints while formulating real-world scenario into database model. ER model is mostly used for the conceptual design of databases. ER model is based on entities and their attributes, relationships among entities, DBMS languages and interfaces. DBMS languages. Data Definition Language (DDL) defines conceptual schema. Storage Definition Language (SDL) is used to specify the internal schema. View Definition Language (VDL) specifies user views or mappings to conceptual schema. Data Manipulation Language (DML) allows user to perform operations such as insertion, deletion, modification, and retrieval. DBMS interfaces. Menu-based interfaces for web clients or browsing. Forms-based interfaces. graphical user interfaces, natural language interfaces, speech input and output, interfaces for parametric users, interfaces for the DBA, database schema, physical schema. Physical schema is a term used in data management to describe how data is to be represented and stored, files, indices, etc. in secondary storage using a particular database management system (DBMS). Example: Oracle IDMS, Sybase SQL Server, etc. In the ANSI, ANSI or SPARC Spark architecture 3 schema approach, the internal schema is a view of data that involve data management technology. This is as opposed to an external schema that reflects an individual's view of the data, or the conceptual schema that is the integration of a set of external schemas. The internal schema was recognized to have 2 parts. The logical schema was the way data were represented to conform to the constraints of a particular approach to database management. At that time, the choices were hierarchical and network. Describing the logical schema, however, still did not describe how physically data would be stored on disk drives. That is the domain of the physical schema. Now, logical schemas describe data in terms of relational tables and columns, object-oriented classes, and XML tags. A single set of tables, for example, can be implemented in numerous ways, up to and including an architecture where table rows are maintained on computers in different countries. Logical schema. A logical schema is a data model of a specific problem domain expressed in terms of a particular data management technology. Without being specific to a particular database management product, it is in terms of either relational tables and columns, object-oriented classes, or XML tags. This is as opposed to a conceptual data model which describes the semantics of an organization without reference to technology, or a physical data model which describes the particular physical mechanisms used to capture data in a storage medium. The next step in creating a database after the logical schema is produced is to create the physical schema. User, workbench, metadata, data browser, query view, mapping view, schema view, manager, enumerator, competence test facility, query engine, rewriter, I/O, prologue KB, subschema. A subschema is a subset of the schema and inherits the same property that a schema has. The plan or scheme for a view is often called subschema. Subschema refers to an application programmer's, that is, user's view of the data item types and record types which he or she uses. It gives the users a window through which he or she can view only that part of the database which is of interest to him. Therefore, different application programs can have different view of data. Syntax for identifying the CA/IDMS subschema. The illustration below shows a sample SYSIN member identifying
the CAIDMS subschema in the extract program. To select specific record from a subschema, include as many REC lines as required. The pref suff prefix suffix is equal to no parameter removes the CAIDMS prefix or suffix added to element names from the TIBCO object service broker control table entries. The default specification for this parameter is yes. Sub EMP SS01.tstdnwka prefix suffix pref suff is equal to no schema empschm, 100 rec s010 data dictionary name or tstdict dictionary subschema name, subschema, column 5, optional, record name, schema name, schema version. Advantages of DBMS: redundancy can be reduced, sharing of data, data consistency, supports transaction, integrity can be maintained, integrity constraints, data security, backup and recovery procedures. Data independence. Summary. In this class, we have learnt about an overview of database system, an introduction to database management system, advantages of DBMS,